Bismillahir Rahmanir Rahim. In this section, we are going to speak about the exponential and logarithmic equations. We have two parts. The first part will be about the exponential equations, and the second part will be about the logarithmic equations. So starting with the exponential equations. For the exponential equation, we have one theorem, we call the theorem of equality. That will be the equality of exponent theorem. Say that if b to power x equal to b to power y, then x equal to y. So if we have equality between two exponents, then x equal to y, provided that b is greater than 0, positive number, and b is not equal to 1. So we have, under these conditions, b is positive number and b greater than 1. If we have equality b to power x equal to b to power y, then x equal to y. Based on this one, we can solve exponential equations. For the exponential equations, it is just an equation, equality between two sides. Maybe both of them have exponents, or one part is written as exponential function while the other is just a constant number. For example, let's solve the exponential equation. We need to find x. Number one, if you are given 2 to power x equal to 32, I need to find the value of the variable x. If we can write the other side 32 as 2 to power something, then we will have, or then we can apply the equality of the exponent theorem. But we know that 2 to power or 32, we can divide by 2. I will have 16. Divided by 2 equal to 8. Divided by 2 is equal to 4. Divided by 2 is 2. Divided by 2 is equal to 1. So it is 2 to power 5. 32 is equal to 2 to power 5. Now, since we have the same basis, this one with this one, it means the powers will be equal. This will give me that x equal to 5. So the solution for the exponential equation, or for this exponential equation, is x equal to 5. Another example, number 2. So with that we have 3 to power x equal to, let's say, 1 over 81. We know that 81 equal to 3 to power 4. So this will be 3 to power x equal to 1 over 3 to power 4. Or it can be written as 3 to power minus 4. So I have now the same basis, 3 and 3. So the power will be the same. In this case, x equal to minus 4. One more example, number 3. So with that we have 5 to power x minus 2 is equal to 125. 5 to power x minus 2 equal to 125. Then I know that 125 is equal to 5 to power 3. Now, since we have the same basis, then the powers will be the same. It means the power which is x minus 2 equal to 3. I have linear equation in this case. That will give me x equal to 5. So the solution for this exponential equation, that is x equal to 5. One more. Suppose that we have 2 over 3 to power x equal to 27 over 8. This can be written as 2 over 3 to power x equal to 27 over 8 is 3 to power 3 divided by 2 to power 3. Or I can say this is 2 over 3 to power x equal to 3 over 2 to power 3. But since I have in the left-hand side, the base is 2 over 3, but in the right-hand side is the 3 over 2. So I can write it upside down. This is equal to 2 over 3 and change the sign of the power. Now I have the two bases are the same, 2 over 3 and 2 over 3. So I can take the power. I will say that x is equal to minus 3. So x equal to minus 3. Number 5. For that we have 4 to power x minus 1 equal to 16. So 4 to power x minus 1 equal to 16. Then 4 to power x minus 1 equal to 16 can be written as 4 to power 2. So this means that the powers, which is x minus 1 equal to 2 or x equal to 3. So the solution for this exponential equation is that x equal to 3. Number 6. Have 9 to power x equal to 27. Now 9 to power x equal to 27. Let's find common base. 9 can be written as 3 to power 2 or to power x. 27 is 3 to power 3. So this the left-hand side can be written as 3 to power 2x. Right-hand side is 3 to power 3. Now we have the same basis, 3 to power 2x and 3 to power 3, which means the powers will be the same. This one and this one will be the same. So 2x equal to 3, or x will give me 3 over 2. So the solution is for this exponential equation is x equal to 3 over 2. Sometimes the left-hand side or the right-hand side cannot be with the same basis. For example, if I have 5 to power x equal to, I have 5 times 5 is 25 times 5 is 125. But if we have, let's say, 14, 5 to power x equal to 14. Now the number 14 cannot be written as 5 to power something. In this case, if the right-hand side cannot be written as 5 to power something, I will use len or logarithm. In this case, I will say take log to both sides. Since I have 5, I will use the base 5 for this one. So I will have log 5 of 5 to power x equal to log base 5 of 14. Now I'm using the properties of the logarithm since I have the same base 5 with 5. Using the property, I will have only x in the left-hand side and the right-hand side will be log base 5 of the number 14. Number 8. Suppose that we have e to power x minus 1 equal to 3. E is a constant number approximated by 2.71. Now I need to find the value of the variable x. Since we have the base e, I will take len to both sides. So it is len of e to power x minus 1 equal to len of 3. Using the properties of the logarithm, since I have exponential function and logarithm with the same basis, this can be removed. I will have only the power, that is x minus 1 equal to len 3. Move on to the other side, then x will be 1 plus len 3. I will have x equal to 1 plus len of 3. One more example, that's number 9. Suppose that we have 5 to power x minus 1 equal to 7 to power x minus 1. Now, if we have different bases but with the same power, different bases but the power is the same. I have 5 to power x minus 1 equal to 7 to power x minus 1. If we have different bases but the powers are the same, we have special case in this case. Different bases but same powers. In this case, x minus 1 equal to 0. Because we know 5 to power 0 equal to 1 and 7 to power 0 is equal to 1. So they are equal in this case only. If they have the same power, and that power is equal to 0. So different bases, but the powers are the same, then the power will be equal to 0. I have x minus 1 equal to 0. This will give me x equal to 1. So different bases, but the same powers, then the power will be equated to be 0. And we will solve for that variable x minus 1 equal to 0. And we will find that x equal to 0. Sorry, x equal to 1. I have x minus 1 equal to 0, then I will get x equal to 1. So this is the idea of the exponential function. But in some cases, we have different bases, but also with different powers. For example, if I have 5 to power x minus 1 equal to 3 to power, let's say, x plus 2. Now, I have different bases and different powers. In this case, I'm going to take len for both sides and solve it normally. I will say that len of 5 x minus 1 equal to len of 3x plus 2. Using the properties of the logarithm, I have power. The power will be, this power will be written down using the properties of the logarithm. Then I will have x minus 1 multiplied by len of 5. Put it in a bracket because I have two terms, x minus 1. This is two terms. equal to x plus 2 multiplied by ln 3. Now open the bracket. I will have x ln 5 minus 1 times ln 5 equal to. Open the bracket in the right hand side. I will have x ln 3 plus 2 ln 3. Now I have x there and x on the left hand side. So I have to bring them together, put them in one side. If we move this to the other side, I will have x ln 5 minus x ln 3 equal to, this is 2 on the right hand side, ln 3. Bring this to the right hand side will be plus ln 5. Now I have x and x, I will take it as a common factor. Then I will have x, open bracket, will be ln of 5 minus ln 3 equal to 2 ln 3 plus ln 5. Divide by ln 5 minus ln 3. I will get x equal to 2 ln 3 plus ln 5 divided by ln 5 minus ln 3. So this will be the value of the variable x. So in case we have two different bases with two different powers, then we'll take logarithm, either ln or log with base 10 or 5, any base will be okay. So I will get x equal to 2 ln 3 plus ln 5 divided by ln 5 minus ln 3. So this is the idea of how to solve exponential equations. We have different cases. Either the two bases are equal, then we'll say the powers are equal, or the bases are different, but the powers are equal, then we'll say the powers are equal to 0 and solve it normally. Or the two bases are different and also the powers are different. In this case, we'll take ln to the both sides.